Hello everyone, this is educational material on engine fundamental course, and this is the eighth part of the learning material. I just focus on engine main component and subcomponents. The learning objective. After this presentation, the student will be able to disassemble engine component and subcomponent, identify the different part of the gasoline engine according to its classification, and identify the different part of diesel engine according to its classification, and also explain procedures to reassemble engine component. The required materials to practice in the laboratory are the diesel engine, petrol engine, service manual, and also tools. Engine main component and subcomponent. Motor vehicle engine is a heat engine which produces mechanical power required to propel the vehicle. The engine is an assembly of many parts joined together to make it operational. Engine disassembly. A typical engine has many parts. Dismantling an engine is not difficult, but a successful outcome depends on being organized. Professional technicians can skip some of the more basic steps once they have a track record to build on. But the first time you undertake a large project like this, you will want to be more careful not to forget an important step. So the engine disassembly is all about removing the components from the engine. Let's see this picture. In this picture, the engine parts are all mounted on the block. So disassembling of the engine means moving from this stage to this stage. So in this stage or in this picture, all parts of the engines were removed.
The 4AF gasoline engine is composed mainly of these parts. You will learn the specific procedures for disassembling three sections of the engine: the timing belt, the cylinder head, and the cylinder block. First, how to remove the timing belt. First, loosen the alternator and remove the drive belt and water pump pulley. Then, remove the spark plugs using an appropriate SST. For each cylinder, check the spark plug for carbon deposits and signs of burning. Remove the cylinder head cover. Turn the crankshaft in the running direction to align the timing marks on the camshaft timing pulley and crankshaft timing pulley. Position the number 1 cylinder at compression top dead center. Remove the crankshaft pulley using 3 different SSTs. First, loosen the crankshaft pulley bolt, then remove the pulley. Remove the timing belt covers and timing belt guide. At this time, with chalk or a similar marker, draw an arrow showing the rotating direction on the rear side of the timing belt and idler pulley. This enables keeping the same fit of the timing belt. Loosen the idler pulley bolt. Loosen the timing belt and temporarily tighten the bolt. Then remove the timing belt and idler pulley. Be careful not to bend or twist the timing belt excessively. Do not allow the belt to come into contact with water, oil, or steam. Remove the crankshaft timing pulley and camshaft timing pulley. This completes removal of the timing belt. Next, the cylinder head is removed. Remove the distributor, water pump, alternator, carburetor, and manifolds in advance. Measure the camshaft thrust clearance. To do this, attach a dial gauge vertically to the camshaft end and move a screwdriver back and forth in the clearance. The standard clearance values are shown here. If the clearance exceeds the maximum permissible value of 0.11 millimeters, replace the camshaft or the cylinder head. Remove the intake and exhaust camshafts. Turn the intake camshaft until the service bolt hole comes to the top. With the service bolt hole in this position, the number 1 and number 3 cylinder cam lobes will push their valve lifters evenly, minimizing the load from the valve. Then remove the number 1 bearing caps of the intake and exhaust camshafts and remove the oil seal. Holding the intake camshaft with a wrench, secure the subgear to the driven gear with a service bolt. Remove the intake camshaft bearing caps in this order: number 5, number 2, number 4, and number 3. To remove the bearing caps, uniformly loosen the bearing cap bolts little by little. For the number 3 bearing cap particularly, loosen the bolts very carefully, little by little, in several passes, so that excessive force is not applied to the thrust portion. To remove the subgear by removing the intake camshaft, mount the hexagonal wrench head portion of the camshaft to a vise using a protector made of aluminum or the like. Insert 2 bolts in the service holes of the camshaft subgear as shown. Inserting a screwdriver between the 2 bolts, remove the service bolt while removing the camshaft. Remove the snap ring using an SST. Remove the wave washer, subgear, and camshaft gear spring. Since the subgear is retained by the camshaft gear spring, be sure to fix the subgear with a service bolt. Then remove the camshaft. To measure camshaft gear backlash, reinstall the intake camshaft with the subgear removed and the bearing caps on the cylinder head. Moving the camshaft, measure the backlash with a dial gauge applied vertically to the teeth surface of the exhaust camshaft gear. The maximum permissible backlash is 0.3 millimeters. Turn the exhaust camshaft so that its knock pin comes to the position shown, allowing the number 1 and number 3 cam lobes to push their valve lifters evenly. Remove the exhaust camshaft bearing caps in this order: number 5, number 2, number 4, and number 3. When removing the number 3 bearing cap, loosen the bearing cap bolts little by little, carefully, in several passes, as with the intake camshaft bearing caps. Now the camshafts have been removed. During these procedures, be careful not to apply excessive force to the camshafts or damage the thrust portion on the cylinder head side with a tool or other object. This could cause problems such as camshaft seizure or breakage after the engine is reassembled. Now the cylinder head's removed. Using an SST, loosen and remove the 10 cylinder head bolts in this sequence. Then remove the cylinder head and gasket, taking care not to scratch the cylinder head and cylinder block surfaces. Disassemble the cylinder head. First, remove the valve lifters. Using an SST, release each valve spring retainer lock. Then, remove the valves, valve spring retainers, compression rings, and valve spring seats. Remove the oil seals. This completes cylinder head removal. Now let's look at the procedure for removing the cylinder block. First, disconnect the oil pan from the cylinder block using an SST. Then remove the oil strainer, the oil pump, and rear oil seal retainer. Measure the connecting rod thrust clearance with a dial gauge attached to the connecting rod cap. The standard thrust clearance is 0.15 to 0.25 millimeters, and the maximum permissible clearance is 0.30 millimeters. If the clearance exceeds the maximum value, replace the connecting rod with a new one. Before disassembling the cylinder block, stamp a match mark on each connecting rod and bearing cap. For example, stamp 1 mark on the number 1 connecting rod and bearing cap, 2 marks on the number 2 connecting rod and bearing cap, and so on. This helps ensure correct reassembly. Remove each bearing cap and place a short vinyl tube on each connecting rod bolt so that bolts do not scratch the cylinder bore surface. Carefully remove the piston and connecting rod assemblies from the cylinder block. Before removing the crankshaft, measure the crankshaft thrust clearance with a dial gauge. The standard clearance is 0.20 to 0.22 millimeters, and the maximum permissible clearance is 0.30 millimeters. If the clearance exceeds the maximum value, replace the thrust washers. Remove the crankshaft. Gradually loosen and remove the crankshaft bearing caps in this order. Then remove the upper bearings and thrust washers. Arrange the removed bearings, bearing caps, and thrust washers in order so that they can be reinstalled in their correct positions. Here, let's look at the method of measuring the oil clearance of each crankshaft bearing. Install the upper bearing on each bearing cap, aligning the oil holes. Place the crankshaft on the cylinder block. After cleaning the journal bearing with waste cloth, set a piece of plastic gauge axially on the crank journal and install the bearing cap. Apply a thin coat of engine oil to the threads and bearing surface of each bolt. Do not turn the crankshaft during measurement. The cap tightening torque is 610 kilograms per centimeter. Remove the bearing cap and measure the width of the plastic gauge at the widest portion. The standard oil clearance is 0.015 to 0.033 millimeters, and the maximum permissible clearance is 0.10 millimeters. If the oil clearance exceeds the maximum value, replace the bearings. Also, measure the oil clearances of the connecting rod bearing and camshafts using the same method, using plastic gauge. Finally, disassemble each piston and connecting rod assembly. Remove the piston rings using a piston ring tool. Using 4 different SSTs and a press, remove the piston pin from each piston. To do this, set the SSTs at these positions to ensure that the load is applied vertically to the piston pin. Never pry the piston pin, or it could become unremovable. Slowly and carefully apply pressure to remove the connecting rod from the piston. This completes cylinder block removal.
After disassembling the engine in the laboratory, now we can study the components. So identification of gasoline engine, stationary, rotary, and reciprocating parts. It is convenient to introduce the various components of the petrol engine in the following group: engine block and crankcase, piston and ring, connecting rod and bearing, crankshaft assembly and bearing, cylinder head and gasket, valve train and timing drive, engine support mounting. Engine block and crankcase. Engine block forms the main structural component of the engine and performs several important functions. The engine block provides a cylinder house to act as a pressure vessel and guide and bearing surface for the piston. The block forms a jacket to contain a liquid coolant. It provides external mounting surface for various engine auxiliary units. The crankcase provides an enclosure for the crankshaft and various other parts of the engine mechanism. Pressure conduits incorporated in the crankcase to convey oil to the engine working parts. The main structure of an engine typically consists of cylinders, coolant passage, oil galleries, crankcase, and cylinder head. Engine block construction. The engine block construction takes two forms: closed deck construction and open deck construction. The closed deck construction, which represents long established practice and resembles a deep box-like enclosure for the cylinder barrels that also serve as a coolant jacket. So this picture illustrates the closed deck type of engine block construction. So the deck is closed. Transfer ducts are provided in the top face or closed deck of the cylinder block so as to permit the circulation of coolant to the cylinder head. So let's see the part of the closed deck construction. Here, a hole for valve pushrod, cylinder bore, water jacket for cooling system, and for timing gear. And this bore is for camshaft. And we have a mounting for oil pump. The second type of the engine block construction is the open deck construction. In the case of the open deck construction, the cylinders are exposed to the outside. So there is a free space comparing with the closed deck type. So the cylinder barrels are freestanding, and that they are attached only to the lower deck of the cylinder, which in past application utilize detachable cylinder liners that tend to result in a less rigid construction. Material. Engine blocks are normally cast from either cast iron or an aluminum alloy. Aluminum blocks are much lighter in weight and transfer heat more effectively to coolant, but iron blocks retain some advantage, such as durability and reduced thermal expansion. Cylinder bore. The cylinder bore constitutes the most important feature of the cylinder block, since they act as a guide and a sealing surface for the sliding piston and ring. Their accuracy of machining must be such as to minimize any out of roundness and taper effect, and to ensure that they are truly at right angles to both the crankshaft and the top deck of the block. The cylinder bore must also be given a carefully controlled surface finish. Crankcase construction. For inline and V-formation engine, the most commonly used form of crankcase resemble a tunnel structure, which extend downwards from the cylinder block. The roof is formed by the lower deck of the cylinder block, and it is closed off at the base by either a detachable sump or transmission housing. The crankshaft is under slung in the crankcase and supported by front, intermediate, and rear main bearing bulkhead that form a series of crank chambers. Piston and ring. A piston is a component of reciprocating engine, reciprocating pump, gas compressor, hydraulic cylinder, and pneumatic cylinder, among other similar mechanisms. It is a moving component that is contained by a cylinder and is made gas tight by piston ring. The main function of the piston itself is twofold. It acts as a moving pressure transmitter, by means of which the force of combustion is impressed upon the crankshaft through the medium of the connecting rod and its bearing. By supporting a guiding pin, the piston provides a guiding function for the small end of the connecting rod. Piston ring. A piston ring is a metallic split ring that is attached to the outer diameter of a piston in an internal combustion engine or a steam engine. To perform its sealing function efficiently, the upper part of the piston is encircled by flexible metal sealing ring known as piston ring. There are typically three in number for petrol engine. The upper compression ring must maintain an effective seal against combustion gas leaking past the piston into the crankcase. This ring also provides a means by which surplus heat is transmitted from the piston to the cylinder wall and thence to the cooling jacket. The lower oil control ring serves to control and effectively distribute the lubricating oils thrown onto the cylinder wall, consistent with maintaining good lubrication and unacceptable oil consumption. Next is the piston and the piston ring. This is a piston with three rings: the top ring, the second ring, and the oil ring. Connecting rod and bearing. A connecting rod, also called a con rod, is a part of a piston engine which connects the piston to the crankshaft. Together with the crank, the connecting rod converts reciprocating motion of the piston into the rotation of the crankshaft. The connecting rod is required to transmit the compressive and tensile force from the piston. And it is most common form in an internal combustion engine. It allows pivoting on the piston end and rotation on the shaft end. The connecting rod is attached at what is termed its big end to the crank pin and at its small end to the gauge pin at the piston. Material: carbon steel, iron-based sintered metal, microalloyed metal, microalloyed steel, ferroiodized graphite cast iron, billet, T6 2024 aluminum alloy or T651 7075 aluminum alloy. Connecting rod bearing. Connecting rod bearing are small cylindrical components that connect the connecting rod to the crankshaft in an internal combustion engine. They are typically made of a high-strength alloy and are designed to withstand the tremendous force generated by the engine's operation. The bearing acts as a buffer between the connecting rod and the crankshaft, providing a smooth and durable surface for the two parts to move against each other. Crankshaft assembly and bearing. A crankshaft is a mechanical component used in a piston engine to convert reciprocating motion into rotational motion. The crankshaft is a rotating shaft containing one or more crank pins, which are driven by the pistons via the connecting rod. The crank pins are also called rod bearing journals, and they rotate within the big end of the connecting rod. Most modern crankshafts are located in the engine block. They are made from steel or cast iron using either a forging, casting, or machining process. Cylinder head and gasket. The cylinder head, often abbreviated to simply head, sits above the cylinders and forms the roof of the combustion chamber. Inside valve engines, the head is a simple sheet of metal, whereas in more modern overhead valve and overhead camshaft engine, the cylinder head is a more complicated block, often containing inlet and exhaust passage, coolant passage, valve, camshaft, spark plug, and fuel injector. Most straight engines have a single cylinder head shared by all of the cylinders, and most V engines have two cylinder heads, one per bank of cylinder. Cylinder head gasket. It is used to seal the contact between head and block. A static seal or head gasket possesses the necessary degree of both plasticity and elasticity. The effect of tightening down the cylinder head on the block places the gasket under compression so that sufficient friction is created between the sealing surface to resist extrusion of the gasket by cylinder gas pressure. Apart from maintaining a seal, the gasket material must also be able to withstand the intense heat of combustion, the penetrating effect of the coolant, and the chemical effect of the lubricant. Type of cylinder head gasket. In earlier practice, cylinder head gaskets for engine of moderate size and power were traditionally of sandwich construction. Asbestos millboard and two sheets of either copper or thin plate steel. Embossed steel sheet type of gasket. Steel and rubber gasket construction. Surface bonded, edge bonded, and surface coated. Cylinder liners. During an earlier era of rapid bore wear, cylinder liners were widely used either as original equipment or as an overhaul feature. Later developments in the field of piston ring coating, lubricating oil formation, oil and air filtration equipment, and cooling system control have all combined to minimize cylinder bore wear, so that the need for detachable liners on this score seldom arises. Cylinder liners are now generally specified either to provide a suitable wear-resistant surface for the cylinders of aluminum alloy engine or to simplify the production of cast iron engine by permitting an open deck for form of cylinder block. Cylinder liners can be dry cylinders liners or wet cylinder liners. Dry cylinder liners, which is a detachable dry liner, take the form of a plane or a flanger sleeve, the entire outer wall of which is maintained in intimate metal-to-metal contact with the cylinder block. This is of closed deck construction and may be of either cast iron or less commonly aluminum alloy. Non-detachable dry liners have been cast integrally with aluminum alloy cylinder block of both closed and open deck construction. Wet cylinder liners. The wet type of liner always take the form of a flanger sleeve, the outer wall of which is largely exposed to the coolant in the cylinder jacket. It may be incorporated in both closed and open deck cylinder block construction. Clearly, the wet cylinder liner is better cooled than the dry type and can more easily be renewed when worn, as will be explained later. It contributes little to the rigidity of the cylinder block, however, and there is always possibility that coolant leak into the crankcase may occur. Valve train and timing drive. The overall function of the valve train and timing drive is to provide First, for the admission and then the retention of the combustible charge with the cylinder, and finally for the release of the burned gas from the cylinder, all in synchronism with the motion of the piston. To perform this sequence of events in accordance with the requirement of the four-stroke cycle, a command follower mechanism driven at one-half crankshaft speed is used to operate the engine inlet and exhaust valve. From this picture, you can see the different parts of the valve train and timing drive mechanism. So the number one, this is VVTI control solenoid. So variable valve timing. And number two, the camshaft position sensor. And number three is the water temperature sensor. And number four, the crankshaft position sensor. And number five, is VVTI actuator. Engine support mounting. The engine is subject to complex vibration effect, which may produce 6 different free motions or degrees of freedom and combination of the same. This motion can generate what are termed bounce and yaw about vertical lag, fore and aft movement, and roll about a horizontal longitudinal lag, and sideways shake and pitch about a horizontal lateral lag. This is the engine mount or support. Apart from supporting the static load of the engine unit and isolating the car structure from engine vibration, the engine mount also insulates the engine against vibration of the car structure and mechanism. A widely used type of support mounting is the sandwich unit, which generally consists of either a rectangular or a circular block of rubber with a metal attachment plate bonded to its upper and lower face. Thank you for watching this video. If you are interested, please share with your colleague. Thank you.